Hi everyone, we're now going to do some precision measurement on an angle. This is the angle in question. We need to find out what theta is, what the angle is. We're going to use a couple of pieces of equipment for this. Firstly, there's this guy. This is a dial test indicator. As you can see, there's a dial there, and if I raise and lower it, the needle spins round. And then there's a sine bar. Sine bar, extremely accurate. The wheels here are exactly 100 millimeters center to center, and it's dead parallel. The other thing we'll need are some slip gauges. These are slip gauges here. This is a box. There's some already out of the box, and they are for, well, exactly that, just slip gauges. These are so accurate, in fact, that they are only accurate at 20 degrees Celsius. To sort of give you an idea of how accurate they are. Now, so the process is, we have the sine bar, place our block on top, then raise one end, and using the dial test indicator, we need this to be horizontal. So this needs to stay, the needle needs to stay in the same position all the way across, which currently it's not. My hand is not the right size. So first thing, we'll get a rough idea of what the size is. So this is a 15 millimeter block. So I'll start with that. Lift it up. Place the gauge on. Now the good thing about these, you can sort of rotate the dial around, so you know where 0 is, and wind it across. You can see it's increasing in size. So the 15 mil is too big. All right, now let's try 14. So again, that's at 0. Wind it, and you can see immediately it's going backwards. And it's going backwards quicker than the 15 went forwards. So the point is, it will be closer to 15 millimeters than it would to 14. Now, what we need to do is stack up these blocks. So we have some here. This is a 3 mil and a 2 mil, just as an example of how accurate they are. They can be rung together, which is basically you hold them at 90 degrees to each other, a little bit of downward pressure, and rotate them. And then just by virtue of being as flat as they are, they'll stick together. Okay. They come in tiny increments. So the smallest one we have is this one. It's 1.005 millimeters. Then we've got 1.01, so at thousandths of a millimeter, and then tenths of a millimeter, and then whole millimeters. So we're going to start with a 12, and to the 12 we're going to add 1.5. That gives us 13.5, and then to that we're going to add 1.07. So 14.57. Okay, and in truth, it doesn't really matter if your dial's set to 0. If it stays in the same place, that's fine. You can see it's moving back, so that's still not enough. 14.57 is not enough. So we'll try 14.67. So lose the 0.5, get the 0.6, yes. Stick it together. And yeah, as you can see, they're being held just by virtue of being flat. Starting on and winding back. Okay, it's getting closer because the dial's moving a lot less over the length. So that was 6.7. So let's try 7. 1.7 and 1.7. 14.05. Okay, so this is now 14.75. And still going down, but very slowly this time. It's just about there. So I'm going to go with is the what's this? The 1.8 and the 1.005. So there we go. 1.8, 1.005. So that gives us 14.805. Place it on the block. And there we go. The needle stays still. So 14.805. We'll call that H. 805. The length we know. The length is 100. 100. And trigonometry tells us to find the angle. Clues in the title. Sine theta equals H over L. So inverse sine multiplied by H over L equals theta. Yes? So we'll just plug those numbers in. Sine minus 1, 14.805 divided by 100 equals, let's see, shift sine, what was it, 14.805 divided by 100 equals 8.513 or 8.514. 8.514 degrees. That's how we even more accurately measure an angle.